Okay, I am answering one of the questions you sent by email, how to solve a non-traditional opamp circuit. Because they are non-traditional circuits, each one of them is a little different, but I'm going to start by saying, remember that the current on the non-inverting input is the same as the inverting input, and it's 0, and the voltage on the inverting input is the same as the non-inverting input. The second rule is trickier because you need to find a voltage either here, and this is node E, or B, and then mirror to the other one. But the current, I'm already going to write here, these two currents are 0, so I don't need to worry about it. But now I want to know either this voltage E or voltage B. And it turns out E depends on the output of the op-amp. And I don't know the output, it kind of depends on the input. So really, B is my best chance of finding the voltage on the positive side. Here is going to be mirrored to the negative side, is going to be B. So first of all, as soon as I find B, I'm going to find E. B and E are the same. My cat's approaching. Between A and C, okay, he jumped. Between A and C, I can already answer. So the question states that you need to find the voltage, the nodal voltages for all these nodes. And it turns out I already know that A is 3 volts and C is minus 6 volts. So I'm going to write 3 and minus 6. At this point, hopefully you already have 40% of the question done. And now I'm going to use nodal analysis, I guess, here, because there's one node, which is node B, that is undefined in this circuit here. And I'm not going to even color this other side because there is no current here. But there's ground node down here. There's A, there's C, and then there's B. Oh, I'm sorry about the sun. That's going to be painful. Sun's coming right into my camera. All right, so let's do KCL on B. And if you remember, I said it doesn't matter anymore for nodal analysis if you write just the KCL or KCL with ohms. So I'm going to do that. I'm going to assume coming into B, and into B. So I'm going to write that Ohm's law for this one will be 3 minus B divided by 10K plus minus 6 minus B divided by 40K plus 0 minus B divided by 40K equals 0. I'm going to multiply everyone by 40. So it's going to be by 40K. So multiplying by 40K, I get 4 here. 12 minus 4B minus 6 minus B equals 0. So B comes out of this. 4, 5, 6 minus 6B equals 12 minus 6 is 6 minus 6. So B is 1. So now I got 1 volt for B and 1 volt for E. So I already know that B equals E. So if E is 1 volt, I now know the current. Let me change color because this is sort of a second part of this circuit. So now if E is 1 volt, I know that this current here, I1, is 1 volt divided by 1K, which is 1 milliamp. This is Ohm's law. So I ask you on the circuit that you write what you're doing, KCL on B, and then here's Ohm's law. And then I'm gonna do KCL on E. The reason is, actually I don't really need to do KCL, but I want to because this current is going out of that node. I'm gonna assume this current I9 is going in. So I9 equals I1. So I9 is 1 milliamp. So by Ohm's law, I'm gonna say the Ohm's law on that 9K is D minus E divided by 9K is 1 milliamp. Now I know that E is 1 volt, so D minus E equals 9, so D equals 10 volts. I hope this helps. You see that there are several different methods you will be using solving this. Sometimes it's source transformation. I think some people source transformed this and source transformed this. This would have also worked. To find first this voltage, then mirror to E, and then know that this really is a voltage division. So if this is 1 volt, this is 9, you could have used voltage division and said D is 10. Because this current is 0, there's really only these 2 resistors here. Let me know in the comments if you have any questions, or send me an email in case it's urgent.